Fantastic. And I'm Jarrod Vawdrey, Field Chief Data Scientist with Domino. I'm doing a lot of work both with NetApp and also AWS. AWS specifically, we've been recently working with your Trainium hardware and doing some interesting work around there, around speeding up some of our deep learning and generative AI pipelines. And then specifically with NetApp, we've been doing a recent thing too. We just use some connectors that you guys had for a vector database down into your technology. So it essentially made things a lot quicker, but also a lot more secure. We're going to talk a little bit about that here today. But let's go ahead and get kicked off. I'd like to hear about some use cases that you're seeing AI is driving.
Sure. And then in pharma, I think we've seen a lot of use cases that have been around for many, many years that were high performance compute and then emerging to AI. But I think what I've seen folks most excited about over this last year since I've been back are some generative AI use cases. And some specifically, have to do with productivity of researchers, whether that be summarizing voluminous technical documents that no person in their right mind, I think, would want to read on their own, but PhDs have to go read those things. And the other that has been very popular, that has gotten excitement in this client base, are around things like health authority questionnaires. So when the FDA is looking at a product application and asking questions of a pharma company, or in Europe, the EMA, the European Medicines Agency, there's the need to provide this information. And, I've had, folks in pharma tell me that it often takes, 9 to 18 months in order to go generate this information and provide it. And generative AI has been able to cut that down into, hours, essentially. I don't think anyone is yet ready to let Gen AI run just on its own. It's all had human in the loop. But for it to consolidate that information, for the researcher, and then them to be able to go provide that information so efficiently, so fast, it has been a savings of multi-million dollars for pharmas, and of course, a heck of a lot of time.
Fantastic. And just to follow up to that, are you seeing most of the Gen AI use cases with folks getting the most value as internally focused today, or are you seeing some that are patient and end user focused as well?
So I'm seeing more internally focused, or at least that's more what folks are willing to talk about with me. If they're doing more external things, that they're being very cautious about it. Because in addition to pharma, I've dealt with the big payer providers. And there was one payer provider, and I hope I didn't tell the story last year. I won't say which payer provider, but they were looking at one of these generative AI use cases and for their members, and they're really excited about it. They had done proof of concept with it. And then they looked at exactly how many tokens it was going to run for their member base. It quickly became an 8-figure in front of the decimal point cost, and quickly became a non-viable project anymore.
Awesome. How about you? What are you seeing in terms of generative AI and some of the, other AI-driven use cases here in the vertical?
Yeah, I do. Well, yeah, before I jump into any actual use case, actually, I would like to kind of emphasize working in the life science really a privilege, because this life science really the domain with a lot of data. It's a data-rich domain. That's the reason why generative AI can be applied in this domain. Thinking back, when the, let's say, transformer model, right, were first was created, right, in 2018, 2019, right? It's coming from the NLP, natural language. Why? Because natural language also data-rich, right? All the way from the historical, classic works by Shakespeare, all the way to tons of data, content created online, on internet, right? All of this data can be filled into the model training. Same thing in the life science, right? We also have a lot of data. We also have the complex data. So these, and also I feel like the scientists and also leaders in the life science really have the methodology to adopt a new technology, all the way from like a cloud digitalization all the way to AI, right? So I mean, based on the recent Domino survey, I actually pretty surprised. Actually, 98% of like life science companies are using AI, and 95 plus companies using the agentic AI, which is coming out of last year, right? So with that kind of data-rich field, and also with that kind of mindset, I really see a breakthrough happening in life science from the everyone know like last year's Nobel Prize in chemistry, right? So from the AI models in the protein structure prediction and all the way to the genomic mining, there are a lot of like creative deep learning models coming out, all the way from the clinical trials for the drug design. So it's really changed the field.
And James, you brought up a few areas there. Obviously, the large data volumes that are needed. When we talk about Gen AI, we're talking about GPUs. Can you talk about some of the changes that you're seeing in terms of infrastructure requirements as folks start tackling this new breed of use cases here over the last couple of years?
Yes, like so, like as a cloud infrastructure company, right? We want to really know what customer needs, right? So in the high level, what customer want to do is really they have a, as I mentioned, they have a tons of data, healthcare data. They want to transform healthcare data into the healthcare insight quickly, precisely, right? So first of all, they need like a high performance computing resources. And on top of that, as I mentioned, they have the data complexity of the data. The data span across different areas, could be on on-prem data center, could be in the lab, also could be in the cloud, and even in different department, even in different countries, right? So they want kind of like the architecture infrastructure to can really handle the data complexity and also model complexity.
That's great. And then, Richard, I know a lot of the discussions that we're having with NetApp revolve around kind of data, and we very quickly get into kind of data silos and this idea of technology or AI sprawl. Are you seeing the same thing, and how are you seeing customers successfully kind of tackle those problems?
So certainly the sprawl aspect. I've seen some organizations where they started with maybe getting some GPUs into a commodity server. And that started to grow, and IT lost track of where the heck all are these. That was certainly a sprawl that tough to manage. They don't know where they're at. They can't consolidate them. They can't get the best utilization out of them because they're all silos. So you've got GPU sprawl when you can't find them anymore within your organization. That is definitely a sign of too much trouble. I've then seen some organizations look to consolidate, build a center of excellence, where therefore all the users within the company could go access those and get better utilization out of that investment. The data sprawl, issue, we see in multiple forms. I know data scientists like to make copies of their data sets. And if they're doing full volume copies, well, you can be having running up a lot more cost, especially in a cloud provider where you're paying by the terabyte, by the month, etc. So that's a sprawl. And then if your CFO or whatever IT controller is telling you it's time to start cutting your cloud costs, I think then you know that you have had some sprawl. And we have some tools to help you look at these things. So for instance, on a data sprawl on multiple copies of data, we do have some tools that will help you look at, hey, are there multiple copies of the same data set? And that can be a tool to help you know what to clean up. Can also look at what hasn't been accessed in some long period of time. And if you see some data that hasn't been accessed in years, maybe it's time to have the researcher or data scientist move that to a less expensive, tier of storage.
Fantastic. And I know Domino is doing some exciting work with NetApp in terms of this, as those who are using Domino in the room here know that kind of having a system of record is very important, especially when you're in a highly regulated industry. And so some of the work that we're doing with NetApp is around exactly that. How do we make it more efficient to store the data, diff the data, and do some of those more efficient kind of practices there, so you don't kind of exploit out the data sets. Is there any kind of guidance that you have for folks around the other sets of the technology, say within the GPUs? Is there anything outside of kind of the centralized access that you just mentioned?
Sure. One of the things I've seen, for those that were here 2 years ago, if you remember that period of time, no one was getting P4D instances. You just couldn't get them on a spot basis. It was, nodding heads here. You had to reserve those, well in advance. I would like to know, has the same issue taking place now with the H100s? You're not having it. Okay. I was just with some NVIDIA peers, last week, and they were, mentioning they couldn't get H100s, at that period of time. So, last year didn't really have issues with GPU scarcity. The year before there were. Sounds like some may be cropping up here now. A hybrid approach can be a good approach in this realm. And, those who have Domino and are looking at Nexus, might be more inclined to do this than others. So where Domino could move the job between cloud and on-premise or between multi-clouds, NetApp would be the underlying technology behind it to move the data, so that you could run your jobs wherever it was most effective, most efficient to do so. If that meant there was GPU scarcity in the cloud, hey, you could run it on-prem. If it meant that your on-prem environment did not have sufficient resources, but there were spot instances in the cloud, that you could go run that in the cloud. And again, Domino would take care of the job, NetApp would take care of moving the data, making it a seamless experience.
That's great. And I know as a data scientist, kind of being able to do that in a self-service manner as much as possible. I see some people smiling. I know, particularly in life sciences, it takes a little bit to get the permissioning and everything set up within an organization to make that happen. But once you hit that sweet spot, right, it makes it really great for to be able to go out and spin up everything from the software to the underlying GPU or environment that you're working with, all the way down to the actual location of that data storage. We heard a little bit about the GPU storage. I know I'd love to kind of throw that over to you at AWS there. I know we're using you guys a lot, and doesn't seem to be much of an issue these days as it was not too long ago. Is there anything you had related to that there?
Yeah, actually, I want to share kind of the working environment before and after, right? Actually, I just want to share a little bit more about myself. 15 years ago, actually, I was also a research scientist in the Center of Biomolecular Physics in Oak Ridge National Lab. So at that time, our team is using the also on-prem data center, as well as the supercomputer in Oak Ridge, right? Which is past times the name was Jaguar. And then anyway, the computing resource is very valuable at the time. So to get the access to the supercomputer, you have to, let's say, write a proposal a half year ago, and then get approved, and then you have to prepared everything, right? Because when the time is open, you have to make everything ready from the scratch, right? Your programs and your model in simulation environment ready quickly. And then if you're lucky working on a very large system, well, which means each job maybe take a few hours, you can have some time to rest. But let's say if you're working on some smaller system, let's say if you just a few minutes, which means you probably have to run work 24/7, right? And also you have to prepare some in-house programs to do the checks, right? To analyze data, to make sure it's correct. But if there's anything happen, well, sorry, because the next person already logged in, so you have to log off. right? So that's kind of old times. But now with access to the cloud, with access to the GPU instances and also the softwares, right, available, so you can easily run your simulation, run your model training in the cloud, and also we're also bringing, I think, with it's not like just one company's job. I do think we are building the ecosystem for the life science community, right? So we're also bringing, sometimes there are a lot of data regulations, right? Sometimes the data cannot cannot leave certain country, right? Then in that sense, we bring in the model to the data, so make it still accessible. So that's the thing we see totally different nowadays.
Fantastic. And you started to kind of talk a little bit around the data and some of the restrictions there. I know the kind of next category we have is around governance, kind of without the gridlock, right? And I see a lot in life sciences getting access to a data set tends to be as much of an organizational, hey, we need to build some trust in the systems as much as it is actually a technology problem. Can you talk a little bit how you're seeing that out in the field?
Yeah, like mentioned. So of course, like the best scenario is like we just migrate all data into the cloud, right? Into a centralized location, and then everyone can have the access to all data. But we know that's not possible. We because of the complexity of the data, and also and also different teams working on different researches, and so we need to have the centralized governance for the data and for the model. And also sometimes it could be let's say like two different teams, like one output of one team's result, project actually could be the input of the other team, right? So we need better central control and a certain transparency. So like each team work not in the silos. So as that says, I think the Domino is really playing a very important in the roles, and as same as NetApp, right? NetApp more can have the orchestration for the data, and meanwhile Domino can have like centralized governance for the model. So
That's great. Yeah, and thanks for bringing up the Domino governance aspect to it. I think what Domino's been able to release here has been fantastic in terms of both governance around a specific model itself, but also, as you mentioned, you become this interconnectivity across different projects, different teams, different data sets. And I think the process and the framework that we have sits very well for that. I know, Richard, we've done a lot of work with you guys. Also, you kind of mentioned Nexus as well. So I'll give you the same question around the governance piece and how you're seeing that play out.
So it's interesting being in America right now that I don't know what are the real guidelines on AI compliance right now in America. In fact, I was reading this morning that in the big beautiful bill, there was actually something that said states could not put any compliance on AI for 10 years or something. Again, this is not a passed bill, but right, that was part of the discussion being taken place. So I don't know right now what the US is going to do about regulating AI. But I was with one of your industry peers last month in Spain, where they have passed the EU AI Act. And so I think we can assume that Europe will lead on this, and all of our companies are going to have to comply with the European, so we might as well build toward that. I'm not an expert on it by any means, but I can use ChatGPT to get a summary. And essentially, it was saying that AI has to be traceable, reproducible, and compliant. It had categorized different levels of risk. There was unacceptable risk, which I don't think we want to touch that, a high level of risk. And I think that's where we can assume that anything within pharma or medical, will fall. And then there was stuff like limited risk and minimal risk. But I think you have to design for that high risk spot, which essentially had things like you have to have logs that can't be hacked, that you need to save the model and the data. And in those logs, it has to include which human, made changes. So again, that traceability, that reporting. And I think all of us in this industry are kind of used to validated systems, with the FDA. So the idea of needing to reproduce a system isn't necessarily foreign. So what does NetApp do, in conjunction with Domino or others here is that within our platform, it's very easy to go make a compliant copy, a snapshot of the data that is efficient, that's not going to be a full volume copy and take up lots and lots of space, but just a snapshot in time of what, say, that model was, what the data was used, for that model. And as often as you iterate to build that into your system to make those snapshots so that you have a series of models with that data that won't take up a lot of space, and it won't take up a lot of time to go make those copies. So therefore, you'd be protected. Now, we can make those snapshots indelible, so not only they couldn't be edited, but couldn't be deleted for further protection.
That's great. I know one of the other Domino kind of features that overlays on that is the ability to kind of define policies, right? And so as these different geographic regions and government agencies and even internally within an organization are changing, can kind of update and overlay those policies on and lock the data all the way through who's using it, who's editing it, where it's stored, what was the approach, also just the metadata across the top. The other kind of side effect that we're hearing of Domino governance, which is really interesting, is a lot of data scientists are saying to me, hey, I used to go back to a project that someone else did 2 years ago and I have no idea what they were targeting, what were the key performance metrics, who was involved in the project. And so there's kind of this side artifact of governance, which is just making teams play well together and getting some standardization into the process in terms of how you're kind of tracking that. So I just heard this with a company outside of this vertical the other day, and I'm seeing it come up quite a lot. So we've talked a little bit about the governance piece. I know I kind of skipped over a question here, and I wanted to come back to it because I think it's important, but you had brought up the collaboration component. And so how are you seeing companies effectively kind of collaborate between the different people within the kind of team, going all the way from infrastructure, IT, through, we talked a lot about data. So that's usually a database administrator, a data engineer, through the data scientists, ML ops, apps, business folks.
Oh, yeah. That's a really great and important question. So I think before we're talking about which kind of tools or which kind of technology we can use to improve the governance, I think the most important thing is the mindset in the company, right? All the way from the C-level people to the research scientists in each domain, right? And also IT as well. So they should have the mindset of let's say communication and collaboration, right? They should know the governance is not just the late stage checkbox. They have to know it's starting from the very beginning, from the data preparation, right? And we have to track what happened to the data, who has been touched, what kind of process has been processed, and which kind of model, which kind of version of the model, which kind of libraries has been used, right? With that information, we can as I think Richard mentioned, then we can ensure we have the reproducibility, we have the traceability, and then have the governance. So have the mindset, and then on top of that, both teams aligned. Then we can talk about the technology, right? Like the softwares can be used, and and also I don't think there's one company can offer everything. So it's an ecosystem. It's that's the purpose why we are here, like AWS and NetApp and together with Domino, right? So to provide the kind of solid infrastructure in the cloud.
I love that point that you just brought up there around, having the teams working together up front. Too often do I see projects fail, particularly in the data science space, where you go away, you build a model, and then you have to hand it over to a compliance team, and 6 months later they're coming back to you and asking you, how did you come up with these coefficients or everything? You're off working on the next project, and it's hard to replicate the data. So it sounds like what you're proposing kind of aligns, where it's, both teams kind of working in parallel. We're minimizing the risk throughout by working together.
And also, like, the thing is, like, better communication. We can also have a better, like, centralized control. We can also, because all times we have like duplicated, like, computing works, right? Different teams actually working in the similar project. Right? One team probably use, like, let's say they both want to do some protein structure prediction, right? One team probably use, hey, I'm gonna just use on-prem GPU instances for some foundation models. The other team probably, hey, I have access to the cloud, right? I'm gonna just train my own models in the cloud, but actually they are working on the same protein. But with a better communication and also better centralized data governance, so they actually can save a lot of costs. And also, because they're coming from different teams, they probably have different data set, right? So in that sense, if you have like only like subset of the data, then which means biased data. Biased data means bias the model, bias the result, and then you will lose the generalization of the model. So
Point there, and you'd mentioned earlier kind of agentic AI as well, and I'm seeing a lot of repeat functionality across organizations when we come in, and folks are building the same features, doing the same data transformation operations, or they have testing packages that they're using which are the same. So there's this kind of area of, let's pull out some of that functionality and kind of share it across. Kind of within a centralized group, as you were mentioning around the GPU. I'm seeing agentic AI kind of push the boundaries on what MLOps is doing, right? So like tracing is a big thing that's coming out of agentic systems, which applies to MLOps, just traditional machine learning and analytics as well. I think the other thing that's going to kind of come out of that is shared services or operations, as you're mentioning. I think as agents, they're a little bit more complex, and organizations start to think about how to use those. It'll be another area where agentic AI is kind of pushing us to find those shared capabilities. Where are you guys sitting in terms of the agentic AI specifically as it's for life sciences? I know it's kind of a little bit of a buzzword still, and people are kind of defining what it means, but
Yeah, I was going to lead into here of some things that we're building that I think will help with this process, because I do feel like much of pharma's in their earlier stages with it, just as it took years to really get going on generative AI. I think we're in some early phases with it. But when I think about all the data that exists within, some of your companies, and hundreds of petabytes of data. And how do I go find, what I'm looking for? Yes, nodding heads here. One of the things that we announced at NetApp at our conference last year, and it was actually a life sciences pharma example, was to be able to search the metadata of your entire NetApp estate. And the search criteria was diabetes in this one, and looking for any file or object that had something to do with diabetes that could then go built into a training set somewhere. We're also looking at, hey, if you are doing RAG on premise, where the data is. What we've seen is a bloat anytime you vectorize the data, 10 to 20x what the existing data is. And there's a need to make that much more efficient. So if we bring GPUs to the data, where it's stored, and using some IP that we have at NetApp, we can significantly reduce that, make that more efficient, and do the analysis, right there on the array. So as we look at a couple of those things and where that fits into agentic AI, and where that fits into the AI factory, that Nick was talking about, and of course NVIDIA talks about, you may have multiple agents solving different problems here all at the same time in your AI workload factory. And we're aiming to make that more efficient, aiming to make the data more accessible on what data you need, versus looking into a data swamp per se.
That's a great great use case there. We're gonna get cut off, and I wanted to leave some time for folks to ask some questions here. But before I do that, did you have any last thoughts that you wanted to cover here?
I think I'd like to take the audience question. They've been patient, and some are, interested in.
Okay. And how about you, James?
Yeah, let's do it.
Okay. Okay. Sounds good.